Welcome to the Crazy Hat Chemist. So today we're doing another video in atomic structure and electron configuration. So let's get started. BAM! So today we're doing light production from the atom, and this is using Niels Bohr's model that we just discussed. So let's keep on going here with this model. So there's our nucleus. There's our first energy level, that is n equals 1. That is the ground state. The ground state is the lowest energy possible. And then n equals 2, n equals 3, n equals 4, n equals 5. Okay, where can we place electrons? Okay, well first what we need to do is we need to have an input of energy. That input of energy is an absorption of energy. And that energy is equal to Planck's constant times the speed of light divided by the wavelength. That's an important equation for you. So that n equals 1 electron is going to absorb energy. And then that electron can be in a variety of different places. Here are the places of which that excited electron can be that is in the red. It can be n equals 5, n equals 4, n equals 3, n equals 2. Any of those are a excited electron that is greater than n equals 1 energy state here for you. So how is light produced from an atom using the Bohr model as a basis? Okay, so what happens? You see that n equals 5 electron that's in red, that's the farthest one out. It's going to fall back down to n equals 4. And as it falls to n equals 4, it will emit light. Okay, all right, so let's take another example. If that electron absorbed a certain amount of energy and it went to n equals 4, then it drops to n equals, and that electron falls to a lower energy of n equals 3, and then it will also emit light. Okay, here's that other electron in n equals 3. And that n equals 3 electron is going to drop down into a lower energy level of n equals 2. And when it drops into n equals 2, it's going to emit light as it falls. Okay, and then we have that n equals 2 electron, and it's going to fall down to n equals 1, and then that will emit light. Okay, you can actually, it doesn't have to fall down to the very next level. So here's another example, looking at the n equals 4 electron, and it's going to fall into the n equals 2 energy level. And as it falls into the n equals 2 energy level, then that will also emit light. So you should see that there's a variety of possibilities. For example, that n equals 5 electron, that n equals 5 can fall to n equals 4, it can fall to n equals 3, it can fall to n equals 2, it can fall to n equals 1. All of those will emit light of different wavelengths. That is the key. Okay, so the distance of fall is equal to the wavelength of light. The distance of fall is equal to the energy, if you will. Okay, so remember the rungs to the ladder, and the rungs are not equal distance. So even if you fall from n equals 5 to n equals 4 and compare that n equals 5 to n equals 4 fall to the n equals 4 to n equals 3 fall, even if the absolute value of those numbers is the same, the difference of those is the same, and that is a 1, 5 to 4, or 3 to, or 4 to 3. That's a difference of 1. That will not emit the same energy of light or the wavelength of light because the rungs to the ladder are not equal distance. That's very important to understand. Okay, so if you have high energy, you have high frequency and low wavelength. So let's correlate that here. So this one going from n equals 5 to n equals 4, that distance of fall is very, very short. So therefore the energy is small because the distance of falling is small. Therefore the energy is low, the frequency is low, but the wavelength is long. Okay, and if you were to compare that to something like the one that I have here, which is n equals 2 to n equals 1, that distance of fall is much greater of the ones that I have drawn here. And that is high energy, high frequency, and short wavelength. Okay, so there's a correlation between the distance of fall and the energy. They are highly correlated. It's a 1-to-1. Okay, and then it's a correlation between the energy and the frequency, and an inverse correlation to the wavelength. Okay, so here's atomic humor to tidy this up just a little bit. You always got to wait to the end of the video because you might get a little bit of humor out of it. Why does hamburger have lower energy than steak? Well, because it's in the ground state, of course. Alright, that was another crazy awesome video. I hope you enjoyed it. And I hope you enjoyed this hack. Give me a thumbs up if you like that video. Subscribe to my YouTube channel. And have a fantastic, cool chemistry day. Bye now.